Hello everyone. In this video, I will talk about one of the most important arithmetic operational tactics, operand splitting method. Here, let's take a look at question number 1. Calculate 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, etc., etc., until 1 over 99 times 100. So now, the key to this answer would not be to multiply all of the denominators because it would take a lot of time and it is not the point of the question. So if you look carefully, you can replace all the fractions with the following formula, 1 over n times n plus 1. This formula can also be written as 1 over n minus 1 over n plus 1, because if you multiply 1 over n by n plus 1 and 1 over n plus 1 by n, you get n plus 1 minus n over n times n plus 1, which is 1 over n times n plus 1. Next, replace all of the fractions with the following formula that we've learned, 1 over n minus 1 over n plus 1. So here, in the first fraction, for example, n equals 1, so it's 1 over n minus 1 over n plus 1, which is 2. The last one, for example, n equals 99, so the replacement would be 1 over n minus 1 over n plus 1, which is 1 over 99, minus 1 over n plus 1, which is 100. Now, if you remove all the brackets, we can see that most of the fractions can cancel each other out. For example, minus 1 over 2 plus 1 over 2 equals 0. Minus 1 over 3 plus 1 over 3 equals 0. And so on and so forth until only two fractions remain, 1 over 1 and minus 1 over 100. So now if you subtract 1 over 100 from 1, you would get 99 out of 100. Now let's take a look at question number 2. Calculate 2 minus 1 over 6 minus 1 over 12 minus 1 over 20 and so on and so on. So in this question, the key to answering it is also using the same method as before, 1 over n times n plus 1. So if you take a look at all the denominators, they are all a product of two consecutive numbers, right? So for example, 6 is 2 times 3, 3 times 4, 4 times 5, 5 times 6, 6 times 7, and so on until 11 times 12. So we can also replace the fraction, so 1 over n times n plus 1, with 1 over n minus 1 over n plus 1. Now, as we can see, we can replace all of these fractions with the formula that we've just learned. So 1 over 2 minus 1 over 3 can also equal 1 over 6, right? And we can verify it by multiplying the two denominators. And if it does equal the initial denominator, then it is correct. So now let's take a look at the last one, for example. 1 over 11 minus 1 over 12. 11 times 12 does indeed equal 132, so we did write the equation correctly. Now we can remove the brackets and switch the sign inside so that we have this as the resulting answer, right? And now, if you look closely, 1 over 3 minus 1 over 3 can get cancelled. 1 over 4 minus 1 over 4 can also get cancelled until 1 over 12, right? So there's only three fractions remaining. 2 minus 1 over 2 and plus 1 over 12. Now, if you subtract and add these fractions together, you would get 1 and 7 out of 12. Now take a look at this question number 3. So calculate 1002 times 1002 over 1003, right? So here the solution is not to manually multiply 1002 squared. It would take way too much time and it is not the point of the question, right? So we can replace 1002 with 1003 minus 1 and use the distributive property of multiplication to multiply the fraction with every number. So now 1003 here gets cancelled and 1002 remains. And now minus 1 times the fraction still gives us the fraction. So now as a final answer we have 1002 minus 1002 over 1003, which gives us 1001 and 1 over 1003 as a final answer. So now let's take a look at the take-home question. So calculate this using the operand splitting method. Pause the video to think about it. And if you're having difficulty doing it, please check the answer. So here it is. And thank you very much for watching. See you next time.